Alright, so we're going to take a look at example 1 method 2. This method's probably a little more involved than you need it to be for a quadratic, but it does come in handy when you get to more complicated expressions, so we will take a look at it. It probably will not be your method of choice, but it is good to look at it because if you are going to go on into math, you will definitely see this again. Okay, so our inequality that we're looking at is x squared minus 2x minus 3 is less than or equal to 0. So we are looking for where y is less than or equal to 0, so that means below the x-axis and on the x-axis. Okay, so we already know our roots from the previous question because we've already factored it. So I'm just going to remind you that our roots are at 3 and -1. Okay, so you can do that by solving the related equation to find the roots, but like I said, we've already done it. And so what we're going to do is we are going to plot those on our number line. And because we are dealing with an inequality that is less than or equal to, and we want the values that are also on the x-axis, we're going to use closed circles at -1 and at 3. Okay, so what this does is divide our number line up into 3 regions. Okay, all those values for x which are less than -1, all the values for x which are between -1 and 3, and all those values for x which are greater than 3. Alright, so we're going to use the table below here to organize our information. The first thing we want to do is to write in our intervals. So those are the ones that we found on our number line by dividing our region up into 3 parts. So we have x is less than -1, -1 is less than x, which is less than 3, and x is greater than 3. Now what we're going to do now are choose some test points from each region. Okay, so for the region which is below -1, we're just going to pick a number that's in that region. I'm going to pick -2 because it's close to -1. And in the region between -1 and 3, I'm going to choose 0 because that's just a nice number to work with. And in the region which is greater than 3, I'm going to choose the 4 because that's a nice number to work with too. It's actually closer to 3. You could pick 5, 6, or 7, but 4 is smaller, so easier to work with. Okay, so what we're going to do, we're going to find out what our y values are for our inequality when x is -2, 0, and 4. So let's plug in -2, and we get 5. So when x is -2, y is 5, we want to know, is 5 less than or equal to 0? And the answer is no, it's not. So we X this region. Okay, it's not part of our solution. So now we plug in x is 0, and we go 0 squared minus 2 times 0 minus 3, and we get -3. So when x is 0, y is -3, so is -3 less than or equal to 0? Yes, it is. That means this is probably our region. And let me write that again, that looks kind of sloppy. Okay, when x is 4, what is y? Let's plug in 4. We get 5. So when x is 4, y is 5. Is 5 less than or equal to 0? No, it's not. So this is not part of our region. Okay, so what we can tell from our number line and from our table that we've just put together here is that the interval that we're taking a look at are all those values between -1 and 3. So we can write our solution -1, and remember our inequality has a less than and equal to sign, so we want to include the equal to, so we're going to go less than or equal to x, which is less than or equal to 3, and that is our solution. Okay, and in the next video we'll take a look at example number 2.